This is question 6 from the first CSAT sample paper. In this question we're given a function f of x which is a quartic. It depends on some parameter k. So our function is k plus 1 times x to the 4 minus 3k plus 2 times x squared minus 2kx. And we're asked for which values of k is there a maximum at x equals minus 1. I think that means a maximum turning point rather than a global maximum. So we want to find a maximum turning point at x equals minus 1. So if you want to have a go at this question yourself, pause the video now. Okay, so the obvious thing to do is to differentiate to find when there's a turning point at all, and then differentiate again to see where it's a maximum. And there's no reason not to do that. There's no other way of seeing where the turning points of this are. So we'll first differentiate to see where there's a stationary point, and then we'll check where it's a maximum. So differentiating, we bring down the 4, make this x cubed, bring down the 2, make this x, and then this x disappears. And we want this to be a stationary point at x equals minus 1, so we'll just plug in x equals minus 1 and see what happens. So that's making this minus 1 and this minus 1. So this just becomes a minus. We get minus 4 times k plus 1. Minus minus is plus, so we get plus 2 times 3k plus 2. And then minus 2k. And now we can just expand out and simplify to get something in terms of k. But when we do that, we get, let's see, minus 4k minus 4, plus 6k, plus 4, minus 2k. We can see the k's actually cancel to give 0, and the numbers also cancel to give 0. So this is always 0. So there's always a stationary point there. We just need to check when is it a maximum. So that means we need to look at the second derivative now. Okay, so we'll differentiate this again. So we bring down the 3, we get 12 times k plus 1 x squared, then this x just disappears, this term disappears. And again we're looking at x equals minus 1 in particular, so we sub in x equals minus 1, this just becomes 1, so we can ignore it and then we can multiply out. So ignoring this now, we multiply out to get 12x plus 12, and then minus 6k minus 4, and that simplifies to 6k plus 8. And for a maximum, we want that to be negative or possibly 0. If the second derivative is 0, then things get more complicated. So first let's think about where this is negative. Well, we just want 6k to be less than minus 8, we want k to be less than minus 4/3. So if k is less than minus 4/3, then the second derivative is negative, so we have a maximum, so that's fine. The question is, what happens when k is equal to minus 4/3? Because then the second derivative is 0, and we could have a turning point or we could have a point of inflection. So there's a couple of ways to do this. One way is to go back to the first derivative, f dash, plug in k equals minus 4/3, and you know now that x plus 1 is a factor, so you can factorize it and see what the derivative looks like. And if there's a point of inflection, that means the derivative is going to 0 and then turning around again. So for instance, if it's negative, it goes to 0 and then it goes negative again. If it's positive, it goes to 0 and then it goes positive again. That's what happens if there's a point of inflection. If there isn't a point of inflection, then the derivative will go from positive to negative or vice versa. So it will have its own point of inflection at 0, but then it will either go from positive to negative, or it will go from negative to positive. So that means a quicker way of checking is to check the third derivative. Because if the third derivative isn't 0, that means that we basically have a double root in the derivative. So that means it stops at 0 and then turns around again, so there's a point of inflection. So in general it's useful to know that if the third derivative isn't 0, then you definitely have a point of inflection rather than having a hidden turning point. If the third derivative is 0, then you need to just keep on checking more derivatives and it gets more complicated. So we'll check the third derivative and hope it isn't 0, because that means there's a point of inflection. So what is the third derivative? Well, we just differentiate again, and now there's only one term left. We get 24 times k plus 1x. K plus 1 we're saying is minus 4/3. This just becomes minus 1/3, so we're getting minus 8x. And we're plugging in x equals minus 1. So at minus 1 this is 8, and that's not 0. And therefore we have a point of inflection there, rather than anything else. And that means we don't have a maximum. So we only have a maximum in this case where k is strictly less than minus 4/3. So the answer we want is k is strictly less than minus 4/3.